Alright, welcome to exercise 7C or 8C, depending on which textbook you're using. Today you're learning all about logarithms. Now, logarithms are essentially a way to help us calculate the product, so multiplying large numbers. Because if you've got, for example, like 2 to the 3 times 2 to the 7, then you could be like, well, that's 8 times, what is 2 to the 7? 128? And do it that way. But back in the day, they didn't actually know how to multiply things like that. So instead, let's actually do that. 128 times 8, 8 times 8, 4, carry the 6, 2 times 8, 16, plus 4, 2,024. Instead, they were like, well, what's 3 plus 7? Well, that's 10. And what's 2 to the 10? 1,024. And they established a way to multiply large numbers using addition instead. And they did this using this thing called logarithms. And they had massive tables of logarithms, but you're going to do all your logarithms, bar the basic stuff, on your calculator. And the main thing to remember is, if I have x equals a to the y, so for example, 8 equals 2 to the 3, then if you wanted to find out y, it's the log base a of x. So if you didn't know this was 3, it's just a different way of writing the same information, but we can do certain things in this form that we can't in this form. Or sometimes you don't know what it was raised to, or sometimes it wasn't raised to a nice even number, so we can just keep multiplying and figuring it out. So you're going to learn a whole bunch of tools that help you around that. But we've got to get used to using logs first. So for example, in example 11, they say to just rewrite these in logarithmic form. So it's always, you always write log, and then it's base, base 10 of the 1,000 log is short for logarithm, by the way, equals 3. So if we were writing 3 to the 4 equals 81, we didn't know what that 4 equals, or we wanted to do something with that 4, we would write log, the 3 is the base, 81 is what we would have ended up with, and we want to find the power it was raised to. These ones, they want us to rewrite it and then see if it is actually true. So for example here, log base 2 of 16 is 4, which means 2 to the 4 equals 16. We're going backwards. Is that true? Yes. Because 2 times 2 times 2 times 2. Here they've said 3 to the 4 equals 27, which is untrue. 3 to the 4 is actually 81. So for example, if we had x equals log base 3 of 27, then the answer x equals 3, because 3 to the 3 is 27. Or if we'd had x equals log base 3 of 81, x would have been 4, because you're trying to find the power it was raised to. If you want to find logs, so if we have x equals log base 2 of 32, you're trying to find what 2 to the whatever equals 32. To the x equals, well, 32 is 2 to the 5, so x must be 5. So 5 equals log base 2 of 32. It's easier with your tens, obviously. Here we've got x equals log base 10 of a million. That's 6 zeros. So this is 10 to the x equals a million. Because it's 6 zeros, it's 10 to the 6. So x is 6, which means we could rewrite this as 6 equals log base 10 of a million. There's a log button on your calculator, but I'm going to talk to you about that later. Now, it doesn't matter if they're negatives or indices. So this is the same as saying 7 to the x equals 1 on 7, yeah? So this 7 is this one. The 1 on 7 is here. And whatever's here is the power. So if we wanted to know what that is, well, that's 7 to the minus 1, isn't it? So x equals negative 1. And here we've got 8 to the 1/3 equals x. So here the 1/3 was in the position of the x in the previous question. Whatever the base is, that's like the thing you're raising to the power. And the number that the big number in the log, like the main number in the log, is what the answer ended up being. So x to the 1/3, well, that's the cubed root of 8, isn't it? Sorry, 8 to the 1/3, which is 2. And here, x is now down where the 8 was. So we've got x to the minus 1 equals 9. So that's our x. That's 9. And this minus 1 is what we raised it to. X to the minus 1 is the same as 1 on x, which means x must be 1 on 9. Write each statement in logarithmic form and then use the log button on your calculator to approximate it. So the log button on your calculator, it doesn't say it, but it's automatically log base 10. And I'm going to show you how to do it when we do these questions. So first we need to turn this into a log question. 10 to the x equals 750. So this is log base 10, because it's the big number here, of 750 equals x. So you're trying to find what 10 was raised to get 750 as your answer. In the calculator, you do it like this. You're going to do, see this log button? That's automatically log base 10. So it does the little 10 for you. 2.875-ish. Let me... That's not a great thing that, yeah. Okay, so it's automatically log base 10. So over here, you're going to have, it's automatically log base 10, which is why they've given us questions with 10 to the something, because they know that's the only thing on calculators that we can do. Technically there's another one, it's called the natural log, we'll get to that later, of 0.003 equals x. So you're trying to find 10 to the what equals 0.003. So we're going to press log, and then we're going to press 0.003, close bracket, negative 2.523. So if you did 10 times 10 times 10, whatever, negative 2.523 times, you would end up with this. Obviously, when you think of it that way, logs don't make much sense, but they are a very convenient form of mathematics that was discovered and used very much in chemistry. So if you do chemistry, you might have seen the pH equals the negative log base 10 of the concentration of hydronium ions in a solution. Square brackets means concentration in chemistry. And, you know, that if that's between 0 and 7, it's acidic, and if it's between 7 and like 14, I think it maxes out as. Yeah, it's basic. Locating a logarithm. So the only logs that you have on your calculator are base 10. We don't have log base 5 on our calculator. So for these ones, we kind of have to guess. They do have log tables, but you're going to learn a method later on that helps you actually figure out log base 5, log base 32, whatever. So 5 to the 1 is 5, 5 to the 2, 25, 5 to the 3, 125, 5 to the 4, 625. We wanted an answer of 100. So it's between 25 and 125. So 5 to the 2 equals 25. 5 to the 3 equals 125. So log base 5 of 25 equals 2. Log base 5 of 125 equals 3. Log base 5 of 100, it's bigger than log base 5 of 2. And it's smaller than log base 5 of 125 because 100 is between 2 and 125. So therefore 2 is less than what we're trying to find. I'm going to call it x, and it's less than 3. So x is between 2 and 3. So that's kind of the types of questions you're going to get in this exercise. Obviously, I'm going to be recording my solutions to the questions.